So we started last week. So, okay, what we are going to do is the 13th lesson recording, sorry, 13th lesson quiz. We are going to push it to, what is today's date? Today is 4th. So next it will be 11th. So we'll push it to 11th of August. Data then quizzes දෙකක් ඔයගලන්ට වැටෙනවා 13th lesson and this week we are going to I'm going to send you the 6th lesson and 8th lesson. So quizzes දෙකක් වැටෙනවා. I hope you can manage. So please do watch it, do manage your time. මේක දවස් දෙකට බෙදාගෙන පොඩ පොඩ හරි බලලා ඉවර කරන්න. Okay, otherwise it will all accumulate. Okay. Where did we stop? Last week was 28th. Okay, we started pressure. We talked about pressure in general. We started talking about hydrostatic pressure. We talked about characteristics of pressure, like how pressure acts in all directions and pressure at the same level of a liquid is the same, and pressure in a liquid increases with the depth. Pressure doesn't depend on the shape of the liquid column and blah, blah. And we also learned about P equals H rho G. And we also did some questions and we started talking about the hydraulic press. And we also learned about a few calculations with the hydraulic press. Is that right? Up to that point, did you have questions last week? No, all good. Last week stuff all clear, Lamai? Do you all even remember that we did this lesson? Api, last week, api formula එක තමයි ලිව්වේ yes F1 over F2 equals A1 over A2. Sorry, F1 over A1 equals F2 over A2. The examples ගැන අපි කතා කරේ නෑනේ. We only talked about the hydraulic press. So let me get that picture to the whiteboard because we're starting from there. මෙන්න මෙතන තමයි අපි last week නවත්තුවේ. Okay. So let's quickly revise on hydraulic press what we learned. Make a full point එක තමයි අපි චූටි force එකක් දෙනවා චූටි area එකකට, right? We are giving F1 which is a small force. It's only 20 newtons, right? To a small area which is just 2 square meters. And the pressure is generated there. I don't move the board. So, A pressure එක හැමෝම මේ පැත්තට යනවා. Right? So here the pressure will be the same but area is larger. So the force, the generated will also be larger. So hydraulic press is very important when you want a bigger force, but you only can apply a small force. මෙතන මට 20 newtons විතරයි දෙන්න පුළුවන්. හැබැයි මට 400 newtons නිකම්ම generate වෙනවා through this setup. That is why hydraulic press is very important, right? Hydraulic press again, you only need to know the concept. They're not going to ask like questions. Just metana pressure ekama thamai metanath tiyenne, so pressures are equal, right? So make sure that you fully understand that. All right. Now, I may have told you this last week, but there is something called a hoist, right? මේකට මම කෙලින්ම textbook එකේ image එක ගන්නම්, because obviously I am very bad at drawing and it's always better to have an image. Hoist එකක වෙන්නේ ළමයි. Now, පොඩි garage වල නෙවෙයි, someone like, let's say, bigger garages or like vehicle manufacturing factories, they have this hoist. So if you take a vehicle could be very heavy, right? So සාමාන්‍ය කිලෝ ගාණක් බරයි. එතකොට vehicle එකක් දැන් හිතන්න, if you take like a big massive truck, it could even be like tons, the weight, the mass, right? So those kind of things, it's not possible for people to get together and lift. That's not efficient. So there is a separate like a setup, an apparatus which we call a hoist. A hoist is the same as a hydraulic press, just a little different only. ගොඩාක් කියන concept එක එකම වගේ. vehicle එකක් කියන්නේ ගොඩාක් බර එකක් නේ. එයා උස්සන්න මට ලොකු force එකක් ඕනේ. හැබැයි මට තනියෙන් එච්චර ලොකු force එකක් දෙන්න බෑ. So මම පොඩි force එකක් දෙනවා පොඩි piston එකකට. Right? So I gave a small force F1 to a small area A1 and a pressure will be generated here. That same pressure will go to this side. But here the area is higher. Since the area is higher, force generated will also be higher, and that force will be enough to lift this vehicle. Okay, that is a hoist. Again, ඔගන් මේ draw කරන්න එහෙම එන්නේ නැහැ, but you just need to know what a hoist means. Is that clear, ළමයි? Others? Okay. So, yes, I'll explain again. Now in a hydraulic press, we only give 20 Newton force to only a 2 square meter area. Small force, small area, a certain pressure was generated, 10 Pascal. මේ පැත්තට ආවම pressure එක එකයි. But area is larger, 40 square meters. So the force will also be larger, 400 newtons. ඔයා තනියෙන් හිටියනම් ඔයාට 400 newtons දෙන්න බෑ. හැබැයි මෙතනදී ඔයාට 20 newtons විතරක් දීලා you can automatically generate 400 newtons. That was a hydraulic press. Same mechanism is applied here. Where if you take a vehicle, it's quite heavy, right? It's quite heavy. And one or two people cannot lift it, right? No, not like a three-wheeler or a bike. We're talking about, let's say, a vehicle, like a vehicle like a four-wheel, තියෙන proper දැන් ගන්න car එකක් වගේ බර vehicle එකක්, right? So එතකොට ඒ වගේ එකක් මිනිස්සු ගොඩාකට ඇවිල්ලා උස්සනකොට that's just a waste of energy, right? But using a hoist, you give a small force. Here the piston has a small area, just like this. Small force, small area. And that pressure will go here. And here there is a large area. So a large force will be generated. Like here, large area, large force. So a hoist is therefore very, very useful in vehicle manufacturing factories or like garages, in that kind of instances. Is that clear? This is called hoist. මේ hydraulic press එකක්. Hydraulic press එකක් අපිට එක එක විදිහට පාවිච්චි කරන්න පුළුවන්. Hydraulic press එකේ mechanism එක අපි මේ වගේ එකකට පාවිච්චි කරාම we call it a special name. We call it a hoist. Okay? So let's write. Okay. Let's write. Make a draw करना है because that's not important. Hoist a picture banana. You can always refer to the textbook or you can just Google search. You'll find plenty of photos, right? You can write with me. Example one, hoist. Actually, आप मेरे तना मौका example के लिए वध. Uh, no, example one क्या था? Just example to that. लिया करना. And last point I will explain after you write down. Last one I will explain. You don't have to draw, just write this. Make it fast. I'll set a timer for 4 minutes. Okay, Ramai. So that is example. That is one of the examples, right? The second example is make an dakalati. Have you all seen this? Again, I'm taking the photo, the image from the textbook. That image looks quite fake. My textbook image image but have you all seen this particular instrument? Have you all seen this anywhere? Mm-hmm. And what do you call it? Ring? No. Mm-hmm. It's called a jack. Hydraulic jack. So there are different kinds of jacks. Godak will use hydraulic jack. Jack කරන්නේ ලොකු ලොකු දේවල් උස්සන්න බෑ. But ගොඩක් වෙලාවට වාහනයකම ටයර් එකේ පැච් එකක් ගියාම they bring the hydraulic press, they fix it to one side of the vehicle. Sometimes even your fathers may also have it. ඊපස්සේ මෙන්න මේ ලීව් එක තියෙනවානේ. මෙන්න මේ ලීව් එකෙන් අතෙන් හරි කකුලෙන් හරි මෙහෙම පාගනවා. පාගනකොට මේක මේ උඩට ගිහිලා ගිහලා මේ vehicle එක ඉස්සෙනවා. එතකොට ටයර් එක මාරු කරලා ඊළඟ අනිත් ටයර් එක දාන්න ලේසි. So there, I mean, it doesn't look like a hoist or it doesn't look like a hydraulic press. It looks way smaller, but it's the same concept. ඔයාට තනියෙන් එක අතකින් පුළු එක අතකින් හරි කකුලකින් හරි මොකකින් හරි can you lift one side of a vehicle up? I mean, මුළු vehicle එක ඕනේ නැහැ. vehicle එකේ side එකක් අත උගන්න උස්සන්න බෑනේ because it's quite heavy. හැබැයි hydraulic press එකෙන් ඔයා මේකට අතෙන් හරි කකුලෙන් හරි force එකක් දෙනවා. But you are giving a relatively smaller force. But ඇතුලේ hydraulic press එකක වගේම එකක් වෙනවා. ඒක අපිට පේන්නේ නැහැ. But ඇතුලේ same එක වෙලා. So I'm giving a small force. Apparently there's a small piston. And that pressure will transmit through the liquid. ඇතුලේ තියෙන අපේ කියන hydraulic oil කියලා. And there's a larger piston here which will generate a larger force. So the vehicle will be lifted up. ඒක ඔයගොල්ලන් ගොඩක් හිතන්න එපා same concept. ඒක විතරක් හිතන්නකෝ. ඇතුලේ එක විදියට තියෙන්නේ but it's the same concept. Small force, small area you are giving. Large force, large area will be automatically generated. That is a it's not as big as a hoist. This is a hydraulic jack, but it's also very, very useful. Is that clear, Lamai? Is this clear? Okay. Okay, let's write our next example, hydraulic jack. This is enough. I'll set a timer for 2 minutes, quickly, right? Okay, Lamma. Now, the last example is the brake system. Okay, so again, I'm going to take the picture. අපි මේ picture එකම කතා කරා in friction lesson, right? We talked about the same thing. Again, don't worry too much, right? Okay. So when you are trying to stop a vehicle, brake ගහලා දැන් අපි vehicle එක stop කරනවානේ. ඔයගොල්ලන් හිතන්නේ ඔයගොල්ලන් කකුලෙන් පාගන එකෙන් මුළු vehicle එකක්ම stop කරන්න පුළුවන් කියලාද? Because you are applying a very small force. You may have I don't think you have tried driving because you are still too young, but maybe your parents or someone else, when they're driving, you may have seen like can go step brake pad. But still, it's enough to stop the vehicle or slow down a vehicle. So it's a significant force. Have brake pedal then put force. It's not same thing, right? Have you heard of something called the brake coil? Brake system में brake coil. It's also a type of fluid, type of oil. So when you step on the pedal, you are giving a small force, and we have this. मैं कहते connect वेला थी ना मैं master cylinder किया लगा there's a piston and it has a small area. ඔයාවේ දෙන පොඩි force එක මෙතනට යනවා. Right? So you are giving a small force and there's a small area. And hydraulic press එකේ වගේම මෙතන පොඩි system එකක් වෙලා මේ pressure එක මෙතනට යනවා. And we have something called the slave cylinder. Slave cylinder is a large area. It has a large area because see here we have the brake pads. Brake pads කියන්නේ මෙම wheel එකට දෙපැත්තෙන් තද වෙන දෙන්න. So they have a large area. Piston එකක් කියලා කියන්නේ මෙහෙම ඉස්සරහට පස්සට move වෙනවා like you know අර syringes වල තියෙන්නේ. අපිට ඔය injection ගාද්දි syringe එකේ මෙහෙම පිටිපස්සේ piston එකක් තියෙන piston එකෙන් තමයි push කරන්නේ. Right? Okay. So we are giving a small force. Pedal එකෙන් small force එක දෙන්න. හැබැයි මේ piston එකට තමයි යන්නේ. So small force to the small piston, small force, small area at the master cylinder, which will become, here there's a large area, no brake pads, so it will become a larger force and it will press on the wheel, stopping it or slowing the vehicle down. So again, they are also the same thing happens. Is that clear, Laman? Let's write that example as well. Brake system. Lamai, I will set a timer for 4 minutes. Quickly, right? You don't have to draw anything. Okay, Lamai. Can you go to exercise 15.1 එකේ අපි මුලින්ම අර lazy questions දෙකක් විතර try කරා නේද? I think we try any questions? I do remember we tried second and third. Second and third or second and fourth? Did we? Second and third hari second and third ne? Mata try karanna ne ugla fifth ek. Because fifth one is a little bit of an important question where like we connect everything. Today we'll try our best to vela kedan. Okay, can you all try the fifth question? Make it really fast, and then we are moving to gas pressure. If we can finish it soon. Yeah, make it fast. And then we only have upthrust. Quickly do this. Am I done? Others? Um, yeah, okay. One more minute, huh? Just one more minute. Make it fast. Okay, Ramay, I think that's enough time, huh? Okay, a tank with a length 5 meter with 3 meter and depth 2 meter is filled with a um liquid of density 800. I understand that for some of you, the weather is terrible. Yesterday, I'm in Mathura these days, and yesterday the weather was very terrible for us. Not, I don't think as bad as it is for the central province, but it was raining the whole day. But today it was like quite rain. But I hear that in the central province it's a little bad. And yesterday also I saw news that like Hatton and all these areas are getting flooded and the schools have closed and there are power cuts and all that. So I hope you guys are safe wherever you are. And we got cut off school at about 10:30. Ah, Sashil, you're from Kandy, right? Is it still bad? Is the weather still bad? Today it's okay, no? Yeah, same here. But I don't think even yesterday it was terrible for us. It was raining, but that was it. But yeah, just be safe. And so yeah, I understand that some of you may have power cuts because I just got a message. But try to stay in the class. Try to stay in the class. By any chance, if it is not possible, if there's a power cut or anything as such, let me know. I already got a message, so thanks for letting me know. Javindu. So, Javindu, let me know if it's too difficult to stay. Drop me a text and I'll make sure you get the recording. But live class again go honda hinda puluwan tarang inna bari munot it's okay. Okay. All right. What is the pressure at the bottom of the tank due to the liquid? Liquid pressure world, we have already learned an equation. What is it? P equals H rho G. So height of the liquid column ke liye depth hai, right? Height of the liquid column is the depth. Because if you take this tank, tank ke length ka breadth ka apit wadak na, but we only want the height. Height means the depth, right? So depth is 2 meters. That means height is 2 meters. Density is 800 kg m minus 3. G means gravitational acceleration, that is 10 ms minus 2. So 2 times 8 is 16. 0, 0, 0. 0, 0, 0. Pressure we measure with Pascal. So it's 16,000 Pascal. Did you all get this answer? Okay. Roman number 2. What is the force acting on the bottom of the tank? Force the equation the pressure related. Yes. At the beginning, we said P equals F over A. This is common to all solids, liquids, gases. Then, may liquid ke pressure ke bottom mein kadat right? So the pressure will still be 16,000 pascals. Force we don't know. If you take the bottom of the tank, do we know the area? What is the bottom of the tank? It's like a rectangle, right? Sorry. Bottom of the tank is a rectangle and they have given the length as 5 meters and the width as 3 meters. So we can get the area as 15, right? Length into breadth. So 5 meters into 3 meters. On a side area area equals length into breadth. Length is 5 meters. Breadth is 3 meters. So 5 times 3, 15 square meters. So what did you get for force, Lamai? Tell me the answers that you got. Yeah? Because it's multiplication. Then we don't have to take the time to multiply. Yeah. 240 zeros to 9, so 240,000 newtons. Okay. So that is it. Okay, give me 1 second, please. Okay. So we are done with liquid pressure, and we are moving to pressure due to gases, right? Let's quickly do this. Put a topic, pressure due to gases. Pressure due to gases. So in pressure, in pressure of gases, again, we are going to be talking about two types, right? Ekak tamai pressure due to a compressed gas. The other one is atmospheric pressure. So these are the two types of pressures. Okay. And then put a topic, subtopic, pressure due to a compressed gas. Quickly. Okay. So here we are going to do a little activity, right? For the activity, again, I'm going to take the same image as on the textbook because that way we can save some time. But I will explain it one by one. Okay. ඔන්න අපිට තියෙනවා මේ U-shape tube එක, right? A tube that has a U shape, we call it a U-tube. Not like Y-O-U-tube, but U-tube. So what I have done is I have filled water to this U-tube. උතර water දෙපැත්තට ගිහලා balance වෙලා මෙම එක level එකේ තියෙනවා. In this figure A. See එක level එකේ water තියෙනවා. මේ පැත්තේ arm එකට තමයි මම X කියලා කියන්නේ. This arm I call it Y. Okay. And then while the water is just like that, I'm going to take a balloon, right? Balloon එකක් මම blow කරලා, I take a balloon, I blow it and I tie it with a thread. ඊළඟට දැන් මේ ඉතුරු කෑල්ල තියෙනවනේ. ඒ කෑල්ල ගෙනහිල්ලා මෙතනට tie කරනවා. tie කරලා මෙන්න මේ balloon එකේ mouth එක tie වෙලා තිබ්බ thread එක මම දලවනවා. So initially I just tie the balloon so that නිකන් balloon එක tie කරනවා, balloon එක ඇතුලේ gas එක එළියට යන්න දෙන්නේ නැති වෙයි. So there is no effect. So this water level will still be the same. Okay, the balloon එකේ තියෙන gas එක එළියට ගියේ නෑනේ. The air in the balloon stayed in the balloon. So no problem. I just tied a balloon, but nothing changed here. The water level will still be the same. Then what I did was I loosened the thread holding the mouth of the balloon. So the air inside the balloon is coming out. And එයාට යන්න වෙන තැනක් නැහැ. මේක ඇතුලෙන් තමයි ආ යන්නේ. එතකොට මොකද වෙන්නේ? Now inside the balloon, එයා කැමැත්තෙන් balloon එක ඇතුලට යන්නේ නැහනේ. AIR. එයා කැමැත්තෙන් balloon එකට යන්නේ නැහැ. We blow into the balloon, right? So we are pressing or we are forcing the air inside the balloon. We call it compressed gas. Balloon එක ඇතුලේ air particles ඔක්කොම හිර කරලා ඇතුලට දාලා තියෙන්නේ. So it's a compressed gas. So when the mouth of the balloon gets loose, the air particles inside will start coming out with a force, with a pressure. එතකොට මොකද වෙන්නේ මේ ආම් එකට ඒ ප්‍රෙෂර් එක දැනෙනවා. දැනෙනකොට මේ water level එක පල්ලෙහාට යනවා. ඉතින් මෙතනින් පල්ලෙහාට යනවා කියන්නේ මෙතනින් උඩට යනවා. Did you understand what happened in the activity? Just a YouTube with water at the same level. Then here I tied a balloon, but still water at the same level. In the third diagram, I loosen the mouth of the balloon. Now air, the compressed air inside is gushing out of the balloon, and it is obviously released into this arm X. එතකොට මේක level එක පල්ලෙහාට යනවා මේ level එක උඩට යනවා. Okay. Okay, so I have a question. I will label this point as 8. Okay, 1 second. I will label this point as 8. I will label this point as B. Does point A or point B have a higher pressure? In this diagram, we are talking about this diagram. Does point A or B has a higher pressure?
Same, equal pressure.
Equal pressure. Because we're talking about the same liquid and it's the same level. Same liquid, same level means the pressure is the same. So in this particular instance, pressure at A equals pressure at B. Now let's look at the third diagram. Now A has gone down, B has gone up. Now which point has the higher pressure?
Y.
That means point B, no?
Yes.
Okay, Sashali says B, Maria says B. What about others? I only got 2 answers. What about others? Okay, Chaluka says B. Others? Shweta says B. Anya says B. Senadi says B. Anya says B. All right. So a lot of you are saying B. Okay, great. But that's not true. That is not correct. Actually, A has a higher pressure. I will tell you why. Then Balanna, here A and B were in the same level. So it was okay, they have the same pressure. But now A and B are not in the same level. A ගේ level එකේ ඉන්න මෙතන point එක ගත්තොත් මං කියන්නම් යාට C කියලා just as an example. Now since A and C are in the same level, pressure at A equals pressure at C. Okay. What about C and B? Which one has a higher pressure if you take just B and C?
C.
C. I see to උඩින් හැම වෙලේම ළමයි දැන් අපි pressure එක කිව්වොත් ගන්න හිතන්න ඔයා කියලා. Let's say you're sitting අර පොඩි කාලේ අපි කරන සෙල්ලම් like එක්කෙනෙක් පුටුවක වාඩිලා ඉපස්ස හැමෝම ඔඩොක්කුවේ උඩ වාඩි වෙනවා. So එක්කෙනෙක් වගේ ඔඩොක්කුවේ වාඩි වෙනවා, it's not that heavy, so not much of a pressure. Let's say 4-5 දෙනෙක් වගේ ඔඩොක්කුවේ වාඩි වෙනවා, you are at the bottom, so it will be very heavy. ඒ වගේ තමයි හැමලේම ඕනම point එක pressure කියන්නේ යට උඩින් ඉන්නේ කවුද? If you, because යට ඉන්න කට්ටිය වැඩක් නැහැ. If you take B to උඩින් ඉන්නේ just atmosphere. It doesn't get any pressure. But C, it has all these liquid above it. So it gets the pressure. Anyways, in a liquid up ඉගෙන ගත්තා depth එක වැඩි වෙනකොට pressure එක වැඩි. So C has a higher pressure than B. Now we know pressure at C equals pressure at A, no? So here instead of pressure at C, I can write pressure at A. So pressure at A equals pressure at B. Can you all hear me, Lamai? Lamai, can you all hear me? Okay, great, finally. Okay, I'm rainy, so connection is quite bad. I don't know whether it's heavily raining, but I can hear the rain. Probably because of that, but let me share the whiteboard again. Okay. So this is what we were talking about, right? Pressure at pressure at A is greater than pressure at B in this instance. Now I have a question. Okay. So why is the pressure at A higher than pressure at B? කොහොමද එතනට ඉච්චර ලොකු pressure එකක් ආවේ? නිකන් practically හිතලා බැලුවොත්. Here if you see point A and point B both have just atmosphere, right? Point A type point B. If you look at this particular instance, above point A and above point B, it's just the atmosphere. Yes. But here, above point B, it's still just the atmosphere. But above point A, there is that compressed gas that the balloon released. ඒ කියන්නේ බලූන් එක ඇතුලේ හිර කරලා තිබිච්ච ගෑස් එක එයා ටික එළියට යනකොට එයා ලොකු ප්‍රෙෂර් එකකින් එළියට යනවා. That's why it felt so much of a pressure. ඒ කියන්නේ හැම වෙලේම when a gas is compressed, is forced into something, there is a lot of pressure in there. හරියට නිකන් ළමයි ගොඩාක් හිර කළ කාමරයකට දාලා lock කරනවා වගේ. Then there's a lot of pressure inside, right? So just like that. So this is what we call pressure due to a compressed gas. Is this clear to all of you, Laman? All right, can you all draw this? Make a draw කරන්න yeah? Draw this fast. And I'll write a few points. Now look what is because it's pretty clear. Quickly draw these and write these few points. Make it fast. Am I done writing? Anyone who needs more time, or have you all finished? Everybody finished? Give me a thumbs up if you have finished. Okay, great. That's what I'm talking about. Okay. So pressure due to a compressed gas, now we understand, right? So that part is okay. Now we are going to talk about atmospheric pressure. This is also not that difficult. It's quite simple. Let's write the topic. Atmospheric pressure. Okay, so atmospheric pressure kiyan lamai, just like in liquids, do you remember if you take any point, the pressure of the liquid at that point depends on the height of the liquid column above that point. Can be height h rho g කියලා කරන්නේ. ඒ වගේ atmosphere ගත්තොත් atmosphere is everywhere, right? So if you take any point in the atmosphere, හිතන්න මෙන්න මෙතන point එක කියලා, like you just pick one point. How do you determine the pressure at that point? The pressure is because of the weight of the air column above that point. ඒ point එකට උඩ තියෙන air column එකේ weight එක හින්දා තමයි යාට pressure එකක් එන්නේ. Okay. Then if you take like somewhere here, point එකක් ගත්තොත් එයාට pressure එක එන්නේ because of the air column above that point. Okay. So again, let me tell you, if you pick any point in the atmosphere, the atmospheric pressure is because of the air column above that point. Keeping that in mind, can you tell me, will the atmospheric pressure be higher at sea level or at Mount Everest?
Mount Everest.
Okay, others? Okay, others? What was the question I asked? Higher or lower? Highest? Higher the lower the manga hui? Higher, right?
Higher.
Okay. Others? Shweta, what do you think? Anya, Dihansa? Okay, Dihansa? Javindu, Sanjana? All right. Let's think of it like this. So, me tamai sea level, right? So, sea level like roda piga to them Colombo chutta kudai, right? Me sea level, me let's say Colombo. Passe api me gamu Nuvarelia. Sub country, it's quite, the altitude is higher. Then api gamu nikame hypothetical. Now, let's say this is Mount Everest. This is sea level, let's say A. This is like Colombo, Gampa, whatever. B. This is like up country, like Nuvarelia or the hilly area, C. And D is somewhere like Mount Everest, which is very, very high. The altitude is very high. Okay. Put this down. Don't draw this. Make up in note. Don't draw it. So atmosphere indefinitely na, right? So if you take atmosphere, you know Earth what is atmosphere out of the atmosphere there is just space. Atmosphere මේ level එකට වෙනකම්. This is the atmosphere level. මෙතනින් උඩ තියෙන space එක. So this is all the atmosphere, right? If you take point A, right? So how do you take the pressure at atmospheric pressure at point A? That is because of the weight of the air column above point A. If you take point D, the atmospheric pressure is due to the air column above point D. So where is the air column the highest? Where is the at which point is the air column? Does it have like the larger, the greater height? at A or D?
A.
Mhm. Yes. Here the height is higher, here the height is lower. Then where is the atmospheric pressure higher? So then it's not Mount Everest, it's sea level. Sea level එක ගත්තහම යාට උඩින් atmosphere එක ගොඩක් වැඩි, right? So because of that, the weight of the air column above that point is higher. So it feels more atmospheric, it feels a higher pressure. But if you go to Mount Everest, it's like very tall, right? So යාට උඩින් atmosphere එක චුට්ටයි තියෙන්නේ. So එතකොට එතන weight of the air column is lower, so pressure is lower. Right? That is how you get it. So all I wanted to tell you is that pressure at any point in the atmosphere is because of the air weight of the air column above that point. Okay. So let's write that. Matakam Liana. Okay, like this. Am I done? Did you finish writing this? Okay, great. Others? All right. No. Okay, quickly. 1 more minute. Okay, I think that's enough time. Okay, so atmospheric pressure ගැන මුලින්ම හොයාගෙන කියන්නේ මුලින්ම measure කරේ there was an Italian scientist called Torricelli. Okay. So Torricelli used an equipment called a mercury barometer. So I will show you how this mercury barometer is formed. මුලින්ම අපි use කරනවා පොඩි basin එකක් වගේ like a trough kind of a vessel. Something like this, right? And then we are going to fill it with mercury. Okay, we're going to fill it with mercury. Then on the other hand, we are going to take a tube. Like this. Let me move this down a little bit. May tube is about, it has to be about 1 meter long, right? It has to be a tube about 1 meter long and like something like this. Can I change it? Okay, anyways, this is a tube. This is a tube. What I'm going to do is I'm going to fill it to the mouth. I'm going to fill it with mercury. Okay, mercury fill karala. Let's say something like this. I've made this just a bottle, but since I don't have anything in the vicinity to show you, let's say make the tamai tube bigger, right? And I fill it up to the mouth with mercury. And then mouth taka mehema wahala. Ateng wahan nae because mercury is carcinogenic. Mukaking hari wahala. You bring it down and then make a මෙහෙම immerse කරනවා අර mercury basin එක ඇතුළට. ඇතුළට immerse වුණාට පස්සේවා අතහරින් මොකක් හරි එක අතාරිනවා. Okay. So then it would look something like this. And what will happen is that now this was filled with mercury. No? මේ mercury වලින් චුට්ටක් මෙහෙම පල්ලෙහාට බහිනවා. ඒ කියන්නේ මේ tube එක ඇතුළේ තියෙන mercury චුට්ටක් එළියට යනවා. ඔක්කොම නෙවෙයි චුට්ටක් එළියට ගිහිලා මේ level එක මේ ගානට වගේ පල්ලෙහාට එනවා. So this is all mercury. Yeah? This is all mercury. This is what we call a mercury barometer. Up to this point, did you understand how the apparatus is built? Others, it's quite simple. We take a large basin, we take a tube, fill it to the mouth with mercury. We flip it in, upside down, and then we immerse it into the mercury basin. And then some of the mercury in the tube will flow a little out, and then the mercury level will go down, and there will be an empty space here. Clear the thumbs up, please. Okay. So, I don't feel mercury with mercury. I feel the tube with mercury. I feel the basin with mercury. I also feel the tube with mercury. So, it's all mercury. Okay. All right. Then, okay. So, let's see what is in here. මෙතන මොකද්ද තියෙන්නේ? What is here in this space? Okay, I got one answer as air. Any other answers? Any other answers, Lamai? What is in this space? I got another answer as air. Okay, I got another answer. Okay, so for those who said air and those who think it's air, how did air enter to this space? කොහොමද මෙතනට air ගියේ? Because earlier this tube was completely filled with mercury. ඊළඟට මම මෙයාව upside down flip කරලා අරන් යද්දි mouth එක වහලා තිබ්බේ. එතකොටත් එයාලට ඇතුළට යන විදියක් නැහැ. ඊට පස්සේ mercury basin එක ඇතුළට ගියාට පස්සේ තමයි මම mouth එක ඇරියේ. So එයා මේක ඇතුළට යන්න කිසිම chance එකක් නැහැ. So there is no air particles here. And obviously there are no solid particles, because if there were solid particles, we can see. And there are no liquid particles either. So we call this space a vacuum. What is there in a vacuum? We don't know. Right? Science වල එකක් තියෙනවා, අපි සාමාන්‍යයෙන් කියනවා vacuum එකක මොනවද තියෙන්නේ කියලා අපි දන්නේ නැහැ. හැබැයි මොනවද නැත්තේ කියලා අපි දන්නවා. There are no solids, there are no liquids, and there are no gases. No solids, no liquids, no gases, then we call it a vacuum. තව වෙන මොනවද තියෙනවද කියලා අපි දන්නේ නැහැ. Solids නැත්තම් liquids නැත්තම් gases නැත්තම් it's a vacuum. So this space is a vacuum. All right. Okay. Now let's consider 2 points. This is point A. This is point B. And mercury වල density එක අපි දැන්ට density rho කියලාම ගමුකෝ. Without using the value, I'll just use density as rho. Okay. So what can you say about the pressure at point A and point B? Which one has a higher pressure? Does point A have a higher pressure, or point B have a higher pressure, or do they have equal pressures? How does it work? Which point has a higher pressure when you consider A and B? Got one answer. What do others think? Anita's answers එන්නෙම නෑනේ. Come on, ළමයි. What do others think? A the වැඩි, B the වැඩි. It's a simple question. We are talking about the same liquid, right? Same liquid ne. දැන් මෙයාත් mercury, මෙතන ඔක්කොම mercury නේ තියෙන්නේ. Same liquid, same level now. We know pressure at A equals pressure at B. Only Maria gave an answer, and she gave the right answer. Pressure at A equals pressure at B. If you take point A, what is above point A? Is there any liquid above point A, or what else is there above point A? above point A, there is only air. That means atmosphere. ඒක හින්දා අපිට A වල pressure එකට කියන්න පුළුවන් it's atmospheric pressure. So we can say pressure at point A is equal to atmospheric pressure. Why? Because above point A, there is only atmosphere. Above point A, there is only atmosphere. So pressure at A, we can call it atmospheric pressure. What do you think about pressure at B? What do you think about pressure at point B? But if you look at point B, above point B, here we have mercury. Let's say the height of this mercury column is H. තව මෙතන මොකද vacuum එකක්. Vacuum means there's nothing. In a vacuum එකේ pressure එක අපිට වැඩක් නැහැ. But there is mercury here. The height is H. Yes. So pressure of a liquid we calculate using H rho G. So height is H, density is rho, and gravitational acceleration is G. So pressure at B is H rho G, pressure at A is atmospheric pressure. Is that clear? Others? Okay. Since pressure at A is atmospheric pressure, here instead of pressure A, I will write atmospheric pressure. Since pressure at B is H rho G, I will write H rho G. From this, we get a nice equation here. Atmospheric pressure is equal to H rho G. Why is this so important? Because ළමයි මේ equation එක නැත්තම් ඒ කාලේ අපිට atmospheric pressure measure කරන්න කිසිම විදියක් තිබුණේ නැහැ. But through this we can measure the atmospheric pressure. Why? Because atmospheric pressure is equal to H rho G. What is H? This height. That height we can measure. What is rho? Density. Density of mercury we know. What is G? Gravitational acceleration. That also we know. So when you calculate H rho G, that will be automatically equal to atmospheric pressure. Therefore, from this method, we can measure the atmospheric pressure. This is what Torricelli found. Did you understand up to that point? Okay. Then, there are so many things that we need to talk about the mercury barometer. අපි හිතමු මේ mercury barometer එක තියෙන sea level එකේ කියලා. Right? Don't write anything. I will organize. Let's first draw this. මම point එක අපි discuss කරොත් හොඳයි. Otherwise, it will be a little overwhelming. Can you start drawing this, Damai? Then I will write a few points at the bottom. Quickly draw this and write this one point. Make it fast. All right, Laman. Done? Others also? Okay. Right. So there are a few things that, as I said, that we need to know about this particular barometer. Prashna ahana with Prashna ahana points keepyak tira. Okay. So if we look at this barometer, let's say this barometer is at sea level. Right? Itana me barometer kine sea level likhi. If this was at 1 second, why my mouse is not moving. If the barometer was at sea level, amai metana height kenawa 76 centimeters. Okay. So when at the sea level, when it is at the sea level, you get the height as 76 centimeters. So one way you can calculate atmospheric pressure is using this equation. Height 76 centimeters. Then mercury level density samaning densities constant values. When it's mercury, it's 13,600 kgm minus 3 and gravitation acceleration G, you know it's 10. So maybe they calculate karanna puluwa. Or there's a different way how maybe they calculate karan Pascal's willing answer. If you calculate in this way. Or there's a different way how you can express the pressure, atmospheric pressure, that is may height kelim maragena. May height kelim maragena. You can write like this. Atmospheric pressure at sea level. You take this height 76 centimeters. Hg. Hg means mercury, right? Hg can mercury. So centimeter Hg means mercury centimeters. So this is also unit of pressure. Pascal is a unit of pressure. Nm minus 2 is a unit of pressure. This is also one way you can express pressure. Right? එතකොට Pascals මුකුත් හොයන්න නැතුව කෙලින්ම height එක ගත්තා. ඒකට අන්තිමට Hg කියලා දැම්මා. So you get pressure. So this is one way how you can express pressure. එහෙම නැත්නම් you can just use the equation. Height 76 centimeters, you have to convert it to meters. Density 13,600 kgm minus 3. G gravitational acceleration is 10. You can calculate and you can get the value in Pascal as well. But this is a simpler way, right? If you go to like Mount Everest, it would be around 20 something centimeter Hg. We call it mercury centimeters. Okay. So that is one point when it comes to mercury barometer, right? Anitaka thamai, okay. Now, we already talked about the vacuum. So we know that already here there's a vacuum. So that is no problem. I have a question. When I turned this tube with mercury upside down and I immersed it into the container, mercury container, mercury chutta eliyata flow vena. Some of the mercury will flow out and therefore there will be a small gap here, which we call a vacuum. My question is, why did all mercury not flow out? I mean, this is a big content of mercury. මේ ලොකු කන්ටේනර් එකක් නේ හොඳට ඉඩ තියෙනවා. ඒතර මේක ඇතුලේ තියෙන මර්කරි ටික ඔක්කොම මෙහෙම එළියට ෆ්ලෝ වෙන්නත් ඉඩ තිබ්බනේ. But why did that not happen? Do you all have any creative answers for that? ඇතුලේ තියෙන මර්කරි ඔක්කොම එළියට ෆ්ලෝ වුනේ නැත්තේ කියලා. Any answers for that? Yeah. Others? Others? The reason is, as I got one correct answer, it's atmospheric. I'm not watching a It's atmospheric pressure. Okay, so a researcher compatible. Anyways, the reason is ළමයි ඇතුළේ ටික ඔක්කොම එළියට එන්නේ නැහැ. මොකද එළිය because now if you take all these points, above all these points, there is atmospheric pressure. So atmospheric pressure is pressing the liquid down. Because may have a point atmosphere. So atmospheric pressure is pressing this liquid down. Right? So not all the liquid inside the tube can flow out because while it's flowing out, what atmospheric pressure is pushing it down. So it can put only until the atmospheric pressure can balance. So this is atmospheric pressure. Okay. So that is also something important that we need to know. Why did all the mercury not flow out? Because atmospheric pressure is pressing on the surface of the mercury in the container. Okay. Then we talked about the unit, mercury centimeters. Okay. Now I have another question. Right? Question another like a small point. At sea level, අපි මුලින් අපි දැන් discuss script එක ලියන්නමුද? I think that would be better. Point by point අපි යමු. තව points දෙකක් වගේ අපිට තව තියෙනවා discuss කරන්න. Anyways, let's go point by point. Otherwise, you're gonna like get this confused. The height of the mercury. මාතකම ලියන්න. So we talked about the atmospheric pressure, how to express that. Oh, and then we also talked about another point, right? Okay, quickly write these points down, make it fast. Okay, others also done writing these 2 points? Give me a thumbs up if you have finished. Okay. So now the last 2 points, okay. So we mentioned if this was at sea level, the height here would be 76 centimeters. So this is at sea level, right? So difficult to write. Sea level. Therefore, pressure, we can write atmospheric pressure. We can write as 76 centimeter Hg at sea level. Okay. But let's say when we go to the Mount Everest, we know that the pressure is less. Atmospheric pressure is less. We already talked about that. Okay. ඒ වගේ දැන් මේ setup එක මෙහෙම Mount Everest වලට අරන් ගියොත් hypothetically what will happen? මෙයා වැඩිපුර immerse වෙනවා. මේ tube එකම තව වැඩිපුර පල්ලෙහාට යනවා. වැඩිපුර පල්ලෙහාට ගිහිල්ලා only like this much will be left. So this would be, let me get the exact value, 25 centimeters. Okay, so depending on the atmospheric pressure at different locations, this tube will move up and down. If it's, as I said, the sea level, the tube will be up. If it is the Mount Everest, it will go down, right? Mandane goga notice when I may picture ke if it's like clear, but yeah. Something like that. So at Mount Everest, atmospheric pressure would be approximately 25 centimeter Hg. We call it mercury centimeter. So from this, something that we can understand is depending on the location, the atmospheric pressure changes. We anyways know that. Accordingly, what happens is that the tube will immerse less or more. According to the atmospheric pressure, the tube will immerse less or more. Okay. So that is one of the points that I wanted to mention. Okay. And lastly, the other thing that I wanted to mention is, අපි හිතමු මෙයා sea level එකේම තමයි ඉන්නේ. Right? කොහෙවත් නැහැ Mount Everest කොහෙවත් නැහැ, just sea level. Right? This is a mercury container. මම දැන් මේ විදිහට tube එක immerse කරනවා. And I know this height will be 76 centimeters because we are at sea level. Okay. Now what I'm going to do is I'm going to incline. පොඩක් මෙයාව side කරනවා. එයා incline වෙලාම හිටිනවා. Right? That is not a problem. මෙතනදී මම height එක බලන්නේ මේ දිගට තියෙන height එක නෙවෙයි perpendicular height එක. So if the tube is inclined and I still measure the perpendicular height, that will still be 76 centimeters. හිතන්න මෙයාවම මම පොඩ්ඩක් tube එක උඩට ගන්නවා. Still, the height will be 76 centimeters. Okay? And එයා ඕන තව ටිකක් immerse කරන්නත් පුළුවන්, still the height will be 76 centimeters. So at the same position, at the same location, whether you keep the tube upright, straight, or incline it, or immerse it more, or immerse it less, take it a little out, the height of the mercury column will not change. Why? Because the atmospheric pressure will be the same, right? So let's also write that at the same location, however way we position the tube with mercury, the height of the yes. Tika kaduena vacuum එක. Yes. The height of the mercury column will be the same because atmospheric pressure is the same. Okay. These are the main points in a mercury barometer that they will ask questions from. Okay, I'm antim points dekat liya galla mein. So both these points have a little diagrams. Once this is over, we can wrap up. It took a little more time, but yeah, next week අපිට pressure ඉවර කරලා we can start the new lesson. For changes in matter, I will be sending you a note. Huh? There's a PDF note. Quickly write this, Laman. Make it fast. Lama, have you all finished writing? Okay, I'll give you one moment. Okay, Lama, done, right? So let's wrap up and let's see each other next week. So as I said, please do watch the World of Life recordings, and we will be doing the quiz next week. And we'll be finishing pressure lesson and starting changes in matter. I will be sending the note of changes in matter. Okay, Lamai. So